and subscribe my YouTube channel. Consider a rocket. This is just our case is momentum conservation in a variable mass system. Now when a rocket is just before ejection, first let's see parts it has an oxidizer, a fuel system is just exists in the construction of a rocket. Now you can see the parts when the oxidizer is just functioning here and the fuel is just also functioning here. During its function you can see all such a system is just acting to produce that. The pump is just giving to oxidize the system here, just injects a pump. And this rocket is just has this part is just a combustion chamber, space for burning of fuel and gases. Now look here, each and every parts. The fuel injector is just exists here to convert the liquid propellant to the droplets. Now you can see it's just now the system is just combined, and here you see the part here, an igniter is just exists here. You see here part is just how it just ejects. Here is a nozzle, convergent and divergent parts it has. Now this is the whole part of the rocket. Now how it just has a principle as a working process. Now let's see how it just functions. You see here oxidizer is just injected from here and fuel is just coming here. They are just combined here to function here inside this one. You see they are just combined and produces a power for the injection of the rocket. Now after this process it will produce a fire inside the combustion pump, and here you can see here now it just starts to move. As it moves it just injects all such types of fire. This just fire is just a mass which should be just injected. As it moves it's up here down on here, the rocket is just injected forward. You see, within this process it can just go. Now let's summarize the whole thing here. In this process, for this purpose I just use a question which should be just describes about the momentum conservation of a variable system. A 10 kilogram mass explodes and splits into three parts. The first piece has a mass of 2 kilogram and a velocity of -4 and 2 meters per second. The second mass with a velocity of 3 kilogram is moving with a velocity of 5 and -3 meters per second. What is the velocity of the third piece? Now you can see, let's see the conservation of momentum principle here. Now let's see here, this is the part of the system. Here you have M1 and M2. Initially it's just moving. This is before this mass. Now the mass is just split into two parts. This is M1, M2, and this is M1. This is after. You can take this part as just is the mass of the rocket, and this is originally this is a rocket where it is just before is just acting like this one. Initially the velocity of 1 and 2, initial velocity of v1 and 2 is 0. But when after that, after it just starts its motion, the part of the rocket which is just the gas part should be just injected. Here M2 is just injected and the rocket is just left. Here you have V1 and here you have V2. So from conservation of momentum principle, we have that the momentum before P01 is the same as momentum after P02. Then you can see here that M1 plus M2, this is before, and the initial velocity V01, 2, this is just the same as M1 V1 plus M2 V2. Initially this part is just 0, so the whole thing here is just 0. You may have that this is 0 equals to M1 V1 plus M2 V2. Now in our case the question is just given. Now this is for two body problems, two parts. If instead of just a rocket, if this is just an explosion, what is the thing that we are going to follow here? The same thing here, the law of conservation of momentum should be just applied, which means momentum before is equal to momentum after. Thus you can see here that initially this is the mass of the explosion, m times V0 1. This is just equals to, it splits in three parts. The first one is M1 times V0 X1 and V0 Y1, and M2 and V0 X2 V0 V0 Y2, and split the third one is M3, which is just the same as V0 X3 V0, sorry, not V0, and this is just final one, Y3. You can have this one. Therefore this is just initially it is 0 before this explosion. So you can have here that 0 is equal to M1 is 2 kilogram. This is 2 kilogram times the velocity is -4 and 2 meter per second, plus M2 is 3 kilogram. Then this is just has a velocity of 5 and -3. This is in meter per second, and plus M3 is the total mass is 10 kilogram. So 2 plus 3 is 5. 10 minus 5 kilogram is 5 kilogram. Mass is just left as the third piece. This is just the same as Vx3 and Vy. So you can take here that the 5 kilogram mass and Vx and Vy, this is just the same as, all these are just taken to the other side, -2 kilogram and -4, 2, and this is in meter per second, plus 3 kilogram, and this is also minus 5 and -3 meter per second. Therefore you can have here is that 5 kilogram and Vx and Vy, this is the same as -2, and this one is kilogram is just cancelled from all sides. -2 times 4 is +8, -2 and 2 is -4. This is in meter per second. And plus 3 times 5 is 15, -15, minus this one, and minus this one is times this one is +9. This is in meter per second. Then add here Vx and Vy comes 8 and minus 15 is minus 7. Minus 4 and 9 is plus 5. This is just meter per second. The velocity of the third piece is looks like this one, which is just 7 and 5, minus 7 and 5 kilogram meter per second are just the values of this question, the answer. So this is just the answer here. This is just the whole thing about momentum of a variable system.